In this video, we're going to look at using the Pythagorean theorem to actually determine whether a triangle is a right triangle, an acute triangle, or obtuse triangle. This is called the converse of the Pythagorean theorem. Now, the Pythagorean theorem is your a squared plus b squared equals c squared. So if I take this leg and square that value, and I add it to this leg squared, it should equal this hypotenuse squared. When it is equal, it is a right triangle, because in our previous videos, in our previous lessons, we use the Pythagorean theorem only when we're given right triangles. When you're not given a right triangle, it's not going to be equal, right? So that's something that we're going to look at in our next practice assignments. One thing you'll notice here is that this is the Pythagorean theorem that you may know and remember, a squared plus b squared equals c squared. However, you'll notice that with these two examples, it is switched, and I'll show you why in a second. It is okay to write this a little differently. It is okay to write this like this. And this one here. I, however, stay away from doing that because when I see these inequality symbols, I actually think about acute and obtuse. And so I want to show you that writing it as a switched equation like this is actually a little easier to visually understand whether it's acute or obtuse. So let's first look at the acute one. If c squared is less than a squared plus b squared, if I take this hypotenuse, this longest side, and I square it, it should be less than the sum of these two when I add them together, and they're squared as well. Notice how this is a less than symbol. So if I see this less than symbol, I want to automatically think of it being acute. So the hypotenuse is less than the sum of the other two squared. When I look at obtuse, the hypotenuse is greater, hypotenuse squared, excuse me, is greater than the sum of the other two legs squared there. So when I see the less than symbol, I usually think of acute, and when I see the greater than symbol, I think obtuse. Notice how that can become an issue when you write it in the general form like this. If I saw the greater than symbol, I may accidentally think obtuse. But if I switch them and you think of it as comparison from the hypotenuse, it makes it a little easier. Let's take a look at a few practice problems. So is each triangle an acute, right, or obtuse triangle? Now, I don't see any symbol here that says it's a right triangle because I don't know if it's a right triangle or not. However, the hypotenuse is always going to be the largest side. So let's just hypothetically say that this is the hypotenuse. I don't know if it's a right triangle or not, but I do know it is the longest side. So I know that my A value, I'm just going to choose one of these two, 19 or 20. My B value would be the other one. And the C is always going to be the largest side length. So I can substitute that into my formula here. 28 squared, 19 squared plus, whoops, this should be a 20 squared. So, using your calculator, I'm going to do 28 squared is 784. 19 squared is 361. And your 20 squared is 400. Now if I add those together, you should get 761. Now you may have noticed that I put a box here and I've just been drawing these boxes here. That is because I don't know whether it's acute, right or obtuse, and I don't know whether it's less than, equal to, or greater than. So it's not until the end here on this line that I can say that this is going to be greater than 761. So because 784 is greater than 761, remember, this was the hypotenuse. Because the hypotenuse was greater than the sum of the other two, right? So the hypotenuse here was greater than the sum of a squared and b squared. Then I can say that this is an obtuse triangle. It is not a right triangle. Let's take a look at the second one. 25 is our largest number, so this is going to be our C. This is our hypotenuse. I'm going to choose A to be either 8 or 24. The B is, in this case, going to be 24 if I chose A to be A. So now I'm going to write this in my equation. 25 squared, I don't know whether it's less than, equal to, or greater than, 8 squared plus 24 squared. So 25 squared is 625. 8 squared is 64. And 24 squared is 576. So 64 plus 576 gives you 640. I can see that this number is larger, so I'm going to put my little symbol that it is larger. That means that the hypotenuse, remember, this was the hypotenuse, it is less than 640. So let's go back. If the hypotenuse is less than the sum of the one leg squared and the other leg squared, then it is acute. So in this example, this triangle would be acute. Okay? If these were equal, it would be a right triangle. Unfortunately, it is not. I just want to show you one last thing. What if you had done it the opposite way? I mean, we're so used to seeing a squared plus b squared and c squared in this order. So let me do this first example this way instead. It will still work. I could do 19 squared plus 20 squared, unknown, 28 squared. Notice how that I will still get 361 plus 400. I'll get all the way down to this step. And then you'll put in your inequality. And you may accidentally think that this is acute only because in our rule, you see the less than symbol. So you're like, oh no, it might be acute. But notice how I wrote it in the original form. So that's why I always suggest to switch the Pythagorean theorem in a way, in the order. But in this example, this is still an obtuse triangle, even though it's a less than symbol. Why? Because this was still the hypotenuse. Okay, so really my biggest suggestion is to switch the order, make the c or the hypotenuse squared come first.